our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your computer-based numerical and statistical technique, which has been this BNST. That has been the class as your 40th class of the sessions here. In the last of 39 classes, what we had done is your unit 1, which has been that we had done your computer arithmetic errors and rules of equation. And even though we had done in the last classes, that has been the unit 2, and the name of the unit which we have here is your that has been that what we had covered is your interpolations and curve fitting. And today is that has been for unit 3rd. It is the first class of the session. That has been unit 3rd is your differentiation, that has been numerical differentiation and integration. So numerical differentiation and integration, what we have to cover up here is about the question and answer that solve problems. Important points to remember, which has been the method based on the interpolation, and we have to cover up the method based on the finite differences, trapezoidal rules for the numerical integration as well, Simpson 1/3 rule, Simpson 3/8 rule as well, and then we'll discuss about the short questions and the concept chart as well, that what we'll have discussed in the last classes. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and another you can also enjoy the video as well. And that has been the important classes which we are dealing here. So please stay tuned with us and you will get all the lectures with all important one. Let's find it out. And before starting with this, we have to first of all know about the method based on the interpolation. So first we discuss about the differentiation for the equi-spaced, which has been the new uniform data points, for the same we have here. So first we'll discuss about differentiation for equi-spaced, which is uniform data points, and for the same it will be, and so we go ahead to find it out. dy upon dx, these were the formula, you can just write it down, copy it down. dy upon dx for x equals to x0, it will be equals to 1 upon h, start a bracket, power differences operator, y is 0, so y 1 upon 2 forward square, y 0 plus 1/3 cube y 0 minus 1/4 for y 0 plus till whatever the requirement of the question it will be. Now we go ahead for the another one. This is x is equals to x0 here, and for that is we will go ahead further as for d square y upon dx square, that we talk about it. And for x minus x naught, this x is equals to x naught here, equals to 1 upon h square upon, that is being delta square, forward differences operator square, equals 0 minus y cube y naught plus 11 upon 12 forward square cube 4 power y 0 minus 5/6 delta square 5 y 0, and that is being plus 137 upon 180, and this is of power 6 y 0 plus till that we have end up with. Now we go ahead the further which we talk about it, which has been dy upon dx here, that has been x equals to xn, that has been equals to 1 upon h, and yn plus 1 upon backward square y n plus 1 upon 3 backward cube y n plus 1 upon 4 backward 4 y n plus 1 upon 5 backward y yn plus now d square y upon dx square for x equals to xn equals to 1 upon h square backward square yn plus backward cube yn and plus 11 upon 12 backward 4yn plus 5 by 6 backward 5yn and plus 137 upon 180 backward 6yn plus that we have here. Okay, so this is for the differentiation for the equispaced uniform data point, and that what we'll have to talk about it. Now we'll discuss about the differentiation for non-uniform nodal points here. And for the same it will be differentiation for non-uniform nodal points that we talk about it. And so for the same here it will be dy upon dx equals to 2x minus x1 minus x2 upon x0 minus x1 and x0 minus x2, which we have y0 plus 2x minus x0 minus x2 upon x1 minus x0 x1 minus x2 y1 plus 2x minus x0 minus x1 upon x2 minus x0 and x2 minus x1 y2 for the d square y upon dx square is equal to 2 y0 upon x0 minus x1 and x0 minus x2 plus y1 upon x1 minus x0 and x1 minus x2 plus y2 upon x2 minus x0 and x2 minus x1 that we have here. Okay, so for the same we go ahead further, which will be solving it out the questions here for the same, and that has been the important one. So we go for the same here. The question is, from the following table of the values of x and y, obtain dy by dx and d square y by dx square for x equals to 1.2. From the following table of where that is values of x and y, obtained dy by dx and d square y upon dx square for x equals to 1.2. So we made a table here for the same. X upon y. Here it is 1.0, 1.2, 1.4, 1.6, 1.8, 2.0 and 2.2. So values we have here 2.7183, 3.3201, 4.0552, 4.9530, and 6.0496, 7.3891, and 9.0250 here. And for the same, the difference divided differences, the values we have to find it out, and that for the same we have your table as well. So, and that what we'll have to find it out. And we go ahead. So first you made divided differences table here, and which is been as follows: x, and for y. Then we have for forward y or backward operator y, forward square y or backward square y, then forward cube y or backward cube y, then forward 4y and backward 4y, then forward 5y or backward 5y, and last is 6y or backward 6y. So we have as follows: so we go for the value, that is for the first value we did here, and that has been as follows. And the value we have for the first one is 1.0, and y is your 2.7183. that has been given in the questions, as you can see here. And for the next we'll talk about it, that is for the delta y, and the backward delta y is your 0.6018. the next is for 1.2, which has been the y we have 3.3201, and the operator we have for the 0.133 and 3. Then again for the delta y and backward delta y is your 0.7351, and this is your 0.0294. For 1.4 we talk about it, this has been 4.0552, and for this it will be your 0.1627 and 0.0067 that we have. Now for the one after 1.4 we go ahead here in the detail that we have. So we go ahead for the same, and that we talk about it. And so that is we have here, and for 1.4 we had done that, and for that we have your values as well. After that we'll talk about for 0.8978, and then we have your 0.0361 and your 0.0013. the next value taken is your 1.6 that has been given, so 1.6x, and for y it is your 4.95530, and then you have your 0.1988, 0.0080, and this is being your 0.0001. Now for the next we talk about it is 1.0966 and 0.0441 and 0.0014. For 1.8 it will be 6.0496, 0.2429 and 0.0094. The next we have is for 1.3395 and 0.0535. The next is for 2.0, this is 7.3891, and this is for 0.2964. the next is your 1.6359, and for 2.2 it will be 9.0250 that we have for the table, and that has been given here, and that what we'll have to talk about it, about the forward backward differences table here. This has been the forward and backward differences table that we discussed here. So for the same we go ahead and here we take it that has been representing here. So here take x0 is equals to 12 and y0 equals to 3.3201 here, and here for that h is equals to 0.2. So for the same it will be dy upon dx, and x is equals to x naught equals to 1 upon h, the y naught minus 1 by 2 delta square y naught plus 1 by 3 delta square y naught minus 1 upon 4 delta 4 y naught plus upon, that is according to x naught is equals to 1.2 and y naught is equals to 3.3201. we have taken from this, and that is being delta y naught equals to 0.7351 and delta square y naught equals to 0.1627, and for the same it will be delta cube y naught equals to 0.0361 and delta 4 y naught equals to 0.0080 and delta 5 y naught equals to 0.0014. so putting these values in the above equation we get it. So that is being delta y upon dx, where x0 equals to 1.2, which is equals to 1 upon 0.2, 0.7351 minus 1 upon 2 into 0.1627 plus 1 upon 3 into 0.0361 minus 1 upon 4 into 0.0080 plus 1 upon 5 into 0.0014 that we have, and which is being equals to 3.3205 here. So thus we can say that. So for the same we go ahead, and that is being dy upon dx, and that is being x is equals to 1.2, which is equals to 3.3205. so the second derivative that we have here is being d square y upon dx square, and that is being x equals to x naught 1 upon h square delta square y naught minus delta cube y naught plus 11 upon 12 delta 4 y naught minus 5 by 6 delta 5 y naught, and that we have, and on the same putting the values of forward difference in above equation, d square y upon dx square, x equals to 1.2, 1 upon 0.04, 0.1627 minus 0.0361 plus 11 upon 12 into 0.0080 and minus 5 by 6 into 0.0014, that is equals to 3.318 that we have here. Now we go ahead for the next, and that we'll discuss about it, and which has been the another important question here. And you have to calculate the first and the second derivatives of the functions tabulated in the previous examples at point x equals to 2.2 and also at x equals to 2.0. we go for the same. Calculate the first and second derivative of the function tabulated in the previous example, that has been the previous examples at point x is equals to 2.2 and also at x equals to 2.0 that we have. So for the same we go for the same, and since x equals to 2.2 is the last data points in the table, we will be use backward difference to find the derivative here, and that what we'll have to discuss as well. So on the same behalf of it, we go ahead. Let xn equals to 2.2 and yn equals to 9.0250 and h is equals to 0.2 as well. So dy upon dx, x equals to xn, which is being 1 upon h, and that we have here is being the backward operator yn plus 1 upon 2 backward square yn plus 1 upon 3 backward cube yn plus 1 upon 4 backward 4 yn plus 1 upon 5 backward 5 yn, and so on. So according to xn, which is equals to 2.2 and yn equals to 9.0250, that the backward differences that we have, backward yn equals to 1.6359 and backward square yn equals to 0.2964, whereas backward cube yn equals to 0.0535. For the same, it is backward 4 yn equals to 0.0094, where backward 5 yn equals to 0.0014 and backward 6 yn equals to 0.0001 here. So we go for the same, and that what we'll discussed here, and which has been the important one. So of course we go for the same, and that being the according to the conditions that we had given here for yn, that is 0.0014 and y56, and we had putting those values in the above equation, we get here dy upon dx, x is equals to 2.2 equals to 1.0.2, where that has been 1.6359 plus 1 upon 2 into 0.2964 plus 1 upon 3 into 0.0535. For the same, it will be 1 plus 1 upon 4 into 0.0094 plus 1 upon 5 into 0.0014 plus 1 upon 6 into 0.0001. That will give you value 9.0228 here. So second derivative that will be given here. So second derivative that will be given is to be given here is d square y upon dx square, where x equals to xn, 1 upon h square backward square yn plus backward cube yn plus 11 upon 12 backward 4 yn plus 5 by 6 backward 5 yn, and then plus 137 upon 180 backward 6 yn plus. So for the same, putting the values of the finite differences in the above equation, we'll get here it will be d square y upon dx square, x equals to 2.2. So for that it will be 1 upon 0.04 0.2964 plus 0.0535 plus 11 upon 12 into 0.0094 plus 5 by 6 into 0.0014 plus 137 upon 180 into 0.0001, and which will give you the value here as being 8.99 and 2. Now for the next we go ahead, and that what we'll be talking about here in the detail, which is being similarly that using the same formula will get the given below. You have to calculate the first and the second derivative of x equals to 2.0 here, and for this take x n equals to 2.0 and yn is your 7.3891 that we take it here. And on the same behalf of it, that the finite differences will be changed according to the new values of xn and yn. Now the next question we'll discuss here in the next coming class. We're gonna end up with this, and before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. On the same behalf of it, other than CPNST, if I'm talking about, yes, we had done sociology and software engineering, even though we have done your chemistry for class 11th and for class 12 part 1, where in the same phase we have to discuss many more that has been we have to discuss here, which has been your other unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 with the convergence, logarithms and antilog. We had done your reasoning here, in that we had done general mental ability in the logic reasoning of verbal reasoning, and in non-verbal reasoning we had done series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation, analysis and practice question set as well. In quantitative aptitude, we had done started with arithmetical ability, in that we had done operations on numbers, SCF and LCF of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, odds and indices, percentage, profit and loss, ratio and proportion, partnership, and then we had done your that is in many more we have to cover up, of course. And in the same case, we had done your ER diagram. We even though done with English vocabulary, we are dealing with PHP interview questions as well. In the same phase we talk about it, yes, we have to start with the physics. We had started with physics part 1 for class 11, where we had done we had started with physical world, and other than that, in terms of chemistry, we had started with part 2 for the class 11, that has been we had started with unit 9 as being the redox reaction. So we have to further discuss all about it. Coming towards CBNST, that has been the computer based numerical and statistical technique. In that we had done your unit 1, which has been the computer arithmetic errors and rules of equation. In that we had done floating point arithmetic, machine abscon, round off error, chopping error, truncation error, associative and distributive law, and the floating point arithmetic, inherent error, error propagation, numerical instability. In rules of equation, we have to cover the second method, Newton-Raphson method, fixed point iteration method for the simple roots, derivations of their rate of the conversions, static and accelerations of the conversions, modifying Newton-Raphson method to the multiple roots, Birch-White method for polynomial, Weierstrass method for quadratic factor, and computer algorithm of these methods as well. In unit 2, we have to cover up the interpolations and curve fitting. In that we have to cover up the algorithm and the error analysis of Lagrange and the Newton's divided differences, interpolation, relationship in the various differences operator, piecewise linear interpolations, cubic spline interpolation, natural spline, Chebyshev's polynomial approximation, Langkow's economization of the power series. In curve fitting, we have to cover up the linear and nonlinear least square approximation, third, conditioning the least square method, Gram-Schmidt's process of orthogonization, computer algorithm of the least square curve fitting. In unit 3, we have to cover up the differentiation and integration, which we had even though started with, which we have to cover up the method based on the interpolations and the finite differences, Richards and extrapolation. In integration, we have to cover up the errors analysis of the trapezoidal and Simpson method, Newton Cotes integration method, Gaussian integration method, Gauss-Legrand method, Lobato integration method, and Radau integration method, error terms in pertaining into integration method. Unit 4, we have to cover up the solution of simultaneous linear algebraic equation. In that we have to cover up the Gauss elimination method, condition method, condition number, successive over the relaxation method, rate of the conversion. Second, solutions of the ordinary differential equation, we have to cover the single step method, Rangeko the second order, third order, fourth order method, multi-step method, predictor, corrector method as well. In statistical technique, we have to cover up the statistical hypothesis, type of hypothesis, type 1 and type 2 errors, level of significance, test involving the normal distribution as well. So here we're going to end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once.
and even though you can also enjoy the video as well. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.